Hello student, my name is Sudipto Ghosh and today I will be starting the new chapter motion. So first of all, we have to get familiar with this word motion. So what is motion? And with this word motion, that another word comes that is rest. So let's see the definition of motion. Motion is that phenomenon in which an object changes its position over time, and when a body isn't in motion, it's at rest. Now, we will be discussing about this motion throughout this whole chapter, and the picture will be clear with time. So now see what motion and rest are respective. It's the topic. Now let's consider you are traveling in a train here, and you are sitting here, and another person who is not inside the train, outside the train, is standing over here. Now, from your perspective, the whole train is at rest, and the outsider world, including this person, suppose his name is Ram, including Ram, is moving in the backward direction. But from the perspective of Ram, or the person outside the train, is seeing the whole world is at rest, and the train, specifically the train, including you, is moving with this direction. Here we can see with change of frame of references we see different types of motion. From this frame of reference we see the whole train is at rest, but from this frame of reference we see the train is only moving portion and the whole world is at rest. So we can say the motion and rest are respective and just depends on the frame of reference from which we are seeing. Still, now consider about the solar system. There are many planets. Let's suppose our planet, the Earth, and the Sun. From our perspective, we are here. We can see the Earth is at rest, and the Sun is moving around the Earth in a day. So, from our perspective, the Sun is in motion and the Earth is at rest. But when an astronaut from the outer space sees it, he sees that the Sun is at rest and the planets, including us, are moving with time. This is the funda. Now another question arises. So whom should we call moving and whom should we call at rest? It's actually an easy question, because in which case we see this is easier. Now consider about the case of the train. If we have to calculate that, seeing the frame of reference from you, that you and the train is at rest, the whole world is moving, the calculation will be more complex. But if we consider the frame of reference of the boy outside the train, that only the train including you is moving, the calculation is much smaller. So we should take the frame of reference of him, and this is how we should consider the frame of reference, and we should call which one is moving and which one is at rest. Now we define motion with some properties. With the preliminary, these 5 properties, these are distance traveled, displacement, speed, velocity, and acceleration. But in this class we will be talking about these 4 only: distance traveled, displacement, speed, and velocity. Now what is distance traveled and what is displacement? Now suppose a point A and another point B. A person have to go from A to B. Now there are different paths that he can travel through a straight line to B, or A can travel from an other way that includes much distance like this, or he can go in this way, or infinite possibilities. If he goes with this way, we can see he has to move a larger path. Then we say that the path A1, the distance he traveled, the whole distance he traveled, this full path is called his distance traveled. But if we talk about the displacement, the whole displacement, that is the smallest distance between A and B, that is the straight line. So this is called its displacement P2, and this is P1 is another way that where this we call it has a distance traveled. Distance traveled from for only 2 points, that can be anything. We can go with this part with or this route. Every time distance traveled will be difference, or we can go through the straight line also, that is also distance traveled. But displacement for to certain points is always constant. It's always the smallest part joining them. I think the idea is clear about distance traveled and displacement. Now consider two others. The other aim, that is speed and velocity. Remember, when we in the previous slide we talk about two different point A and B. It's right. In the case of velocity, let's take it as a straight line, although it doesn't seem like that, but consider it. Sorry for my poor drawing skill. And this is, there was another way like this, and take another path, that is here. This is path A1, and this is path 2, this is path 3. This, in the case of displacement, we consider the path 2. This is displacement, and with in the case of distance traveled, we can take any path. For path 1, suppose distance traveled is 150 unit, and for the path 2 the distance traveled is 80, and for path 3 distance traveled is 96. Now calculate, if we calculate the speed of the man who is traveling through the path 1, we see the speed of the man is 150 by time taken for traveling through the path. In the case of path 3, we can calculate the speed is 96 by distance traveled and time taken for moving through the path number 3. And in the case of the path 2, we can say the speed of the man is a I think I said it 80 by time taken in this path 2. But if we calculate the velocity, we have to always consider about the displacement by time taken. So for path 1, we can say speed is something 150 by time taken. But if we talk about the velocity, for path 1, time velocity must always be the shortest path, and we know the straight line is path 2, and the shortest distance about A and B is 80. So we have to consider the distance as 80, and time taken is the time of path 1. So for path 1, the velocity must always be less than its speed. I think the idea is clear. And now another word comes, that is average velocity. From before going to average velocity, we should consider the units. What is the unit of distance travel and displacement? You may remember that in the slide where I talked about distance traveled and displacement. I said displacement is the shortest distance travel. So displacement and distance travel are actually quite same, but displacement is always less than or equals to distance traveled. So these two must share same unit. That is, in CGS we say the distance traveled unit is and centimeter, and displacement also say has same unit centimeter, and SI both has the same unit meter. And in case of speed and velocity, they also share the same unit, that in CGS that is centimeter per second, and in SI that is meter per second. Now another idea occurs, that is of average velocity. What is average velocity? Average velocity is the total displacement and the total time taken. So we have traveled through from A to B. Here our total displacement is the straight line, and the total time taken is whatever time we have taken through the whole path. So if we say no, let's consider let's understand it with a question. Let's talk about another question. That here we have this question. Here we see a car travels in straight line. It goes a total of 480 meter, while the first half is travels with a velocity of 30 meter per second, and the second half with a velocity of 60 meter per second. Calculate the average velocity of the car. For any ordinary person, we see that if we talk about any ordinary person who doesn't have the idea of average velocity of the car, that he would see the car travels first half, it means 240 meter. First 240 meter is 30 meter per second and the second 240 meter at 60 meter per second. So the average will be the half of its total, half of its total. So the average must be 30 plus 60 by 2 equals to 45 meter per second. Any ordinary person will say that, but it's actually totally wrong. Now I'll see that how it is wrong. We already said that average velocity is total displacement divided by total time taken. Now we have to calculate the total time taken. Actually, we haven't seen that before. We just calculated the velocities, average of the velocities, and we talk that is the average velocity, but that is not true. That is actually the total time taken and total displacement. So let's calculate the answer. Total time taken in the first half. It has two halves, 240 meter and 240 meter. First half, it travels in the velocity of 30 meter per second, and second half it travels with the velocity of 60 meter per second. For the first half, we can calculate the time taken is 240 divided by 30 meter per second. So we have the time 240 by 30 is equal to 8 meter by meter per second is second. So first half we have the 8 second, and for the second half we calculate in the same way, that it is 240 meter by 60 meter is equal to 4 second. So total time taken is 4 second plus 8 second is total 12 second, and total distance traveled is 80 meter. So the average velocity must be total distance, and we know the total distance by total time. So the average velocity must be 480 meter by 12 second. So the average velocity comes 40 meter per second. Now I think with this question, with the help of this question, the idea of average velocity is clear, and I think it is enough for today, and we will continue it in our next lecture. Thank you.